Hello again. Thanks for joining us. This is Space Nuts. My name is Andrew Dunkley. Thanks for joining us. We've got a big program today. It is jam-packed. We've got 27, at least 27, maybe 6 stories. Here's one. I don't know if you heard the song 1 Million Bicycles in Beijing. It probably wasn't a big hit, but now we're talking 1 million satellites in space. Yep, it's a possible thing. Some good news out of Chile, though. We'll talk about that. Artemis 2, not bad news, probably not surprising news, a launch delay. Space mushrooms, yes, they are real and they are very yummy, apparently. Perseverance is going AI, and they have discovered or confirmed a Martian shoreline. We'll talk about all of that on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And taking a break from a little sojourn to a horrible part of the world in Australia is Professor Fred Watson, astronomer at large. Hello, Fred.
Hello, Andrew. Greetings from Nelson Bay.
Yeah, dreadful, dreadful place. I spent much of my youth in Nelson Bay, just north of Newcastle. It's just, it was a sleepy little fishing village when I used to go there, but now it's just nothing like that.
Well, it's been discovered, hasn't it? That's
Yes,
the
it
thing.
has.
It's 2 hours from Sydney. It's half an hour from Newcastle. It's not really. It's bound to be a target, and it's still got its charm, though. I have to say, as we were talking a few minutes ago, I've been coming here for 43 years, nearly. In fact, it's 43 years, and it's exactly as you've said. It's very, very different.
Yeah,
but it's still. Geographically, it's a lovely spot with Port Stephens, this huge expanse of water with, islands in it and hills all around. Really quite remarkable.
it is lovely, yeah. I miss it a lot. Last time we were there was for a beach wedding, but that's going back a few years. But even then, it didn't look like the fishing village that I grew up, is it?
No, that's right.
While we're talking about different places, I was having a bit of a, I don't know what you'd call it, a jibe at Colorado's cold weather on a recent episode. And I got a note from Michael who said, on the podcast, you're concerned about the frigid temperatures in Colorado. Unfortunately, we've just had one of the warmest Decembers on record with daily highs often 10 to 15 degrees Celsius. That's a winter in Dubbo. Until this weekend, January, was on track to be well above normal. With highs around 7 to 10. And to add insult to injury, our mountain snowpacks are the worst on record. And while our USB 50 ski industry is getting hurt, the real problem is that they rely on melting snow for water. And they didn't get a lot of snow this year. So, that's a scary one. I think a lot of places in the world rely on snow for the spring melt for their water supplies. So hopefully that's just a one-off in Colorado. Got a lot to talk about, Fred. Let's start with this news that we received during the week. It's been highly publicized. Elon Musk, SpaceX, has put in an application to launch possibly 1 million satellites. 1 million. This is a completely different project to that of the internet service that he's been working on. This is another kettle of fish.
It is. It's an orbiting data center. In fact, SpaceX has basically teamed up with another company, an AI company, and together there is this plan to launch not 300,000, 1 million satellites between 500 kilometers and 2,000 kilometers in altitude, and at probably quite interesting inclinations, not far from the equator, and also some which will be in polar orbits. What's the idea? Well, you basically harness the sun's energy using these spacecraft in order to power your data center, and you link them by lasers, essentially optical links, and so the whole thing then engages with Starlink to send the data up and down to the Earth. So it's a wild idea. It fills astronomers with horror because 1 million satellites in orbit is just going to completely pollute the sky. Absolutely. Especially when you have some of them at 2,000 kilometers, which means that they're visible for, in fact, at some latitudes, they'll be visible all night. So that's the latest shock horror. That is a filing that has gone, I think I'm right in saying, to the Federal Communications Commission. I don't know whether it's been filed with the International Telecommunications Union, which is the only international body that can basically regulates space flights. There are many national bodies, but the only international one is the ITU. I would guess they would accept it because they accepted a filing back in 2020 for 300,000 satellites put in by the Rwandan government. But that, if it hasn't already, and I don't think it has yet, that will have expired because I think they've only launched one CubeSat. Rather than 300,000. So it might be a little bit like the Rwandan was, something like putting your foot in the door to stake a claim. But we will see what happens. It's a very interesting development, and as I said, one that scares us to death in the world of astronomy.
It's certainly a divisive issue, and it's not the first time, as you said. The year before last, there were complaints about the Starlink network and the blinding of telescopes. Astronomers got upset about that. Elon Musk has actually rejected those claims, and he'd probably reject these ones too. I mean,
it has to be said, he hasn't really, of all the internet supply companies, of course, Starlink is the one that's most populous. They've got 9,000, a little bit more than 9,000 spacecraft in orbit. Yeah. And SpaceX has worked with the astronomical community to try and minimize their effect. Of all the companies, they've been the most forthcoming. Yeah. But it's hard to see how, when you put it up to 1 million satellites, how you can reconcile that with astronomy.
No.
And I might add, actually, as we speak, there is a meeting going on in Vienna, at which the issue of what we call dark and quiet skies, the idea of satellite constellations, that will be discussed this week. And then,
okay, be interesting to see what comes out of that. We'll leave that one there, but I'm sure there'll be more about it going forward, maybe. Let's go over to Chile, because we talked about an energy project that was being touted for that part of the world, which was going to be very close to some of the most significant telescopes on Earth. The problem with this energy plant was it was going to be basically the size of a small city. So the lighting would have been a major issue, but that seems to have all been scrapped.
Indeed, it has. So the problem was, you're quite right. There are two mountains in Chile which are notable for astronomy. They've both got optical telescopes. One is Cerro Paranal, which houses the VLT, the 8.2 meter telescopes of the Very Large Telescope, as it's called. And it's about 20 kilometers away on the other side of the valley is a mountain called Cerro Amazones, where the biggest telescope in the world is being built, 39 meter ELT, or extremely large telescope. And in that valley, it's where an energy company, AES Andes, they had plans for a factory to use solar and wind energy to make green hydrogen. And exactly as you've said, it was city-sized. It filled astronomers with horror because it threatened to put light pollution into a region which so far has been completely dark, and which houses perhaps the world's most productive and efficient telescope. Certainly when the ELT comes along, there is nothing to touch it anywhere else in the world. It's going to be an extraordinary instrument. But it's been cancelled. The company has pulled out of the project, and I think they've taken note of the environmental damage it would do to astronomy. I think that's been the reason why they've done that. And so all credit to people who've used common sense to to progress things, they'll no doubt put it somewhere else where it might be less damaging, because it is it's an environmentally positive step. Green hydrogen's a great thing to have, but we don't want it there.
No. But hopefully they will be able to put it somewhere else, because it does sound like a good project moving forward. But just not there, not in that place. Hats off to them for making that decision. It must have been difficult, because that's a $10 billion project. That's
very big. Yeah,
that's a lot of bickies.
I suppose that's the ultimate NIMBY, isn't it? A NIMBY process. In my backyard.
In my backyard. We've got a lot of NIMBY projects around here, I can tell you.
Yes.
Wind farms, solar farms, the inland rail. It's all causing a lot of people to get a bit NIMBY. This is Space Nuts with Andrew Dunkley and Professor Fred Watson.
Houston, Tranquility Base here. The Eagle has landed.
Space Nuts.
Okay, Fred, speaking of the moon, let's move our attention to Artemis 2, that mission we talked about last week, which was getting ready for its wet rehearsal and a few other tests and a few checkovers. Mostly things went well, but they did find a hydrogen leak, and that set them back another month.
It's a bit like Groundhog Day, isn't it, really? Because this is exactly what happened with Artemis 1. And in fact, at one point, I think they took the whole spacecraft back into the vehicle assembly building to try and fix the hydrogen leaks. So yes, the wet dress rehearsal was this past weekend, our time, as we are speaking today on the recording. And the hydrogen leak, as I understand it, it's the place where the pipe fits into the tank. It's like on your car. It's where you stick the fuel Bowser hose into your petrol tank. Except it's a little bit more complicated than that. But I think that's where the leak has been, and it's worrying enough to the engineers and the administrators who are overlooking Artemis 2 that what they've done is they said, well, actually, we need to do another wet dress rehearsal when we fix this problem. And that means postponing the Artemis 2 launch from this month, which was what we hoped, to next month, which means March at the earliest. So yes, a push back in the process.
Will they leave the launch vehicle on the pad at this stage?
I think at the moment that's the plan. I haven't heard any hints of it being taken back to the vehicle assembly building. That's a big process. It's a major step to have to do that. So they will certainly, I think, be looking at trying to fix it on the pad beforehand.
Okay, and if they can't, they might have to roll back.
Yeah,
again. But it's all about safety. That's the most important thing. And
yes, absolutely. Yeah,
they want to get this right. So it's better to be a month late or even longer than have something go horribly wrong, which we've certainly witnessed in the past. And we talked about the anniversary of Columbia last week. And it's, those things are still strong in people's minds. You've got to avoid that at all costs. So, hopefully they'll find the problem. Maybe it's a poo valve that's just, not...
Yeah, it could be a poo valve. The real problem is hydrogen atoms are so small.
Yeah.
They're the smallest of all atoms, so they fit through any tiny crack. We had at one time, when I was working as an astronomer at Siding Spring Observatory, not far from you, one of our telescopes used photographic plates back in the day, and to sensitize them, we called it hypersensitizing, we actually had to bathe them in hydrogen for a period of something like 10 hours before they were used, and that increased their sensitivity by several orders, in fact. But the problem was keeping the hydrogen where you wanted it. It tends to leak. It's a very leaky gas because of the small size of the atoms.
Yeah. Well, just look at the Hindenburg. Certainly leaked there.
Yes, that's right.
Yeah. Although, didn't they figure out many, many years later that it wasn't the hydrogen leaking that was the problem? It was the, what do they call it? The stuff in the fabric that caused the problem. Yeah, it wasn't actually the hydrogen that was the issue. It was the it was the static electricity in the fabric, but it was the lacquer. I think the lacquer.
That was my
Yeah.
That could be it. That was my understanding, that it was static electricity.
Yeah. Different story. But Artemis 2 still on the launch pad. Probably the schedule is March the 6th at this stage, but maybe that will change depending on how the next test goes, or the wet rehearsal, or whatever they do. They did want to try and do more than one. So, well, they got an opportunity now. They have to. Now, this story I find fascinating, and I think you've got a personal connection with some of the people involved in this, but they have basically grown mushrooms in space, and then they brought them back and had lunch.
That's right. This is actually a friend of ours, Sarah Webb, who's down in Melbourne. She's an astrophysicist and a science communicator, which is how we worked with her in the past. But she runs a project to basically engage with the International Space Station on behalf of school students. And so this particular project was designed by Sarah and one of her colleagues, plus 12 high school students from Haileybury College in Melbourne, and a lot of help from professional mushroom growers. What they did was they packaged up not the mushrooms themselves, but the things that essentially act almost like the roots of the mushrooms, which are called mycelium, a word I didn't know because I'm not a mushroom expert. The small filaments that are essentially the root network of mushrooms. So that's what they sent up. They were in space for a month on the International Space Station. They came back again with a crew change. And so what the researchers did was to essentially take these mycelium filaments and plant them and turn them into mushrooms. And it worked. It worked well. And so they've now written a rather nice conversation piece, which is entitled, "We Ate Space Mushrooms and Survived to Tell the Tale," which is, I think, quite a nice title.
It is, rather. I was just looking up what the most expensive mushrooms in the world are, and they're the Yatsa gunbu caterpillar fungus. And they cost $50,000 to $63,000 per pound because of their rarity. And apparently they've got medicinal properties, and they grow them in the Himalayas. I've got a feeling these mushrooms, which are based on the lion's mane mushroom,
Yes.
Would be a bit more expensive than that, by the sound of it.
Yeah, they might be by the time you figure in the cost of the International Space Station. That's right. And the lion's mane is the one, it's a species that it's actually the one that they ate. It's just to put this project in context, it's really, thinking about how you might grow fresh food for astronauts on long-haul space missions. If you've got people going to Mars, you're going to have 6, 7, 8 months in the spacecraft. Can you, as they say in their conversation article, how can you continue to nutritionally support those astronauts? And that is essentially one of the motivations for looking at things like growing things in space, giving them the checkout to make sure that they don't turn poisonous by their zero gravity environment, things of that sort. And that's what they've done with this. So very nice experiment.
Yeah, I've been doing a lot of research on how you would feed people on a spaceship for a long haul mission, and that's one of the solutions to have basically small farms on the ship, hydroponics and things like that, and grow your vegetables and your fungi and whatever else will grow easily in space, and supplement the other stuff that you have to take with you, which would be the proteins. But it's a really interesting story, what they can do with food. I mean, if you're going to spend a year out in space or whatever, you can't just rely on packets of chips. And you won't get out of the hatch when you get home. But nutrition's very important, and they've got to get that right too. In time, it's not an easy thing, is it? Going into space when you consider all the logistics involved in feeding and disposal of waste, and all the other things that go with it. Quite extraordinary. But I wonder what they were like. I think the report basically suggests that they were quite yummy.
Yes, that's right. Exactly that. They were very tasty.
Yeah. I wonder, do you think space changes the taste of things?
Well, that might be one of the tests that you do. You take mycelium that's been to space and mycelium that hasn't, and try to contrast the two. I'm sure they've done that too.
Yeah, maybe. It's a great story. You can read it at the Conversation website. It's called "We Ate Space Mushrooms and Survived to Tell the Tale." Love it. This is Space Nuts with Andrew Dunkley and Professor Fred Watson.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
Space Nuts.
Now, Fred, we're going to dedicate the last section of the show to Mars. And this was a story that caught me a little bit by surprise. We've talked a lot about the Perseverance rover and what it's up to. These two stories actually involve Perseverance. But this one, Perseverance has gone AI. No more human drivers. We've left it up to the computers.
That's right. So it's the story is really about the first ever drive on Mars, fully planned by artificial intelligence.
Wow!
And it happened actually at the end of last year. The two demonstrations carried out on December the 8th and December the 10th last year, and it's all about how you plan a route across the terrain of Mars with no manual input, and so it's a process that usually is performed by humans, as you might expect, people on Earth poring over the maps that we've got, the high-resolution images that have been taken by Mars Reconnaissance Orbiter and things of that sort. So what they've done is given all that to the AI machine and said, okay, we want to get to there. How do we do it? And basically, that's what they've done, and there's a very nice report on this on the space.com website that gives us a map showing the planned and the actual routes that were taken by the Perseverance rover, and it just goes to show how close the actual route was to the planned route, which means that they didn't encounter unexpected obstacles and things of that sort.
Yeah, that's very unlike when I used to go in the car with my grandmother. I remember one day we turned into the highway and she was on the wrong side of the road.
Oh, dear.
But anyway, that's not a problem on Mars.
No, there isn't a wrong side of the road on Mars. That's right. I suppose, getting off your beaten track is, but there isn't a beaten track. That's the other thing. So you're always on virgin territory when you're driving a spacecraft on Mars. I think it's a step forward because I think there's quite a lot of work goes in to the human planning of the routes to Mars. It's a labor-intensive process. In fact, I might read a little bit from that space.com article, which is really sums up the whole process. Because Mars is an average of 150 million miles or 225 million kilometers from Earth, communication delays make real-time control impossible. For decades, mission teams have instead planned daily routes by hand. Human drivers analyze the terrain and rover status data, then map out paths using waypoints, typically spaced no more than about 100 meters, 330 feet apart, to avoid hazards. And then these plans are sent to Mars via the Deep Space Network, where the rover executes them. So this is really, a step forward. If you can get AI to do all that, then the other mission scientists could go and do something else, like analyze what the sample gatherers are telling us about the terrain on Mars.
Yeah, it's a big leap forward, really. And when you think about it, I mean, they've done it pretty tough trying to make decisions about where to go and how to do it. And if you have to make a direction change, the time factor is like 4 minutes up to 24 minutes to get the message to Perseverance. And then you've got to wait that time again for the message to come back saying, no, we hit a rock.
That's right. Yes. So, yeah, exactly. So, that's why you've got to upload the instructions beforehand. And if AI can help with that, so much the better.
Yeah, incredible. Yeah, I mean, you hear a lot of doom and gloom about AI from certain commentators. It's going to be the end of humanity. That's the extreme. But it's so useful. Like even in general day-to-day stuff, it is so very useful. I was trying to look something up the other day and I could not get the wording right in my browser for it to look up what I wanted. It doesn't happen often like that, but it was driving me nuts. So I just went to AI mode and went, I want to know this. And it went ding, 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 done. It's pretty impressive stuff. Really impressive stuff. And we're only at the very dawning of it, aren't we, really? It's only in the early days. And it makes me wonder, Fred, what we can use in terms of AI as day-to-day people. What have they got going in secret, in the dark rooms of the military and places like that? Their AI systems must be amazing.
Yeah, that's where it really starts worrying, when you let robots go off and kill people.
Yeah, that'll happen one day. Yeah. I don't doubt it. But a fantastic story about Perseverance using AI technology to find its way around, and maybe it'll miss those rocks now. And you can read it at space.com. Still on Mars and still on the Perseverance rover. This is a fabulous story to finish on, Fred. And this is, I think we've talked about the potential for a shoreline being suggested for Mars, but now they reckon they've actually uncovered definitive evidence of it.
That's right. Yes. So you're absolutely right. There's for a long time there have been features in the geomorphology of Mars, the layout of the land, that suggest shorelines from this hypothetical ocean, which the evidence is building, probably covered the northern hemisphere of Mars for a long period. We've talked about several stories recently that seem to be confirming that it was a large body of water rather than just a few lakes that came and went with the climate. It's one thing identifying possible shorelines from orbit, but it's quite another to have definitive evidence on the ground, and that's what Perseverance seems to have found now with an analysis of rocks. And we're still talking about Jezero Crater, which is where the spacecraft is. Remember, it's this crater that we believe was once full of water, and there's a river delta on one side of it, which is what Perseverance is looking at. But the shoreline hypothesis comes about, and this is actually from studies carried out by scientists at Imperial College in London. What they've done is they've looked at, it's an area which is called the margin unit. Interesting. It sounds a bit more like a jazz combo to me, but it's the margin unit. That's the name of this geological feature. And it's got a double whammy in terms of the way its history has evolved, because there's signs of what's been called subsurface water activity, where you've got water that is changing the characteristics of rock. And I think the thinking, summarizing it very quickly, and I hope I'm doing the scientist justice in doing this, what you've got is basically, it starts off with volcanic rock, But that rock is then altered by water and turns out to have, to be sort of carbonaceous after that, carbon dioxide, rich water underground, circulating underground. It gives a chemical alteration to the landscape underground. And so that's one of the things that this study has revealed, that is almost certainly what happened. But the other thing is the fact that they now see evidence of a shoreline in terms of basically the layers. There are structures in the sandstone, which is kind of what it is. It's this altered rock, which match structures, as they say, typically formed by wave action on a shoreline.
Yeah.
And a lovely comment from one of the researchers: "We are looking at what was once a beach." That's Alex Jones, who's a PhD student at Imperial College, and he's the lead author of this study.
Yeah, it's fascinating.
So,
I think for me, Fred, the most exciting part of this story is that they are suggesting this discovery pushes back the timeline for conditions that would support life on Mars. So does that mean that the time frame is much larger than they originally thought?
Yes, I think that's the bottom line, that you're giving yourself a bigger window in which life could form on Mars. So yes, it is a very nice piece of work. Once again, it's just adding to the growing body of evidence that we are amassing, that yes, Mars once had a climate very like the Earth's.
Yeah, and may well have had life as a consequence of that. And now that the window is bigger, my brain is saying it's only a matter of time before we find the evidence. And whether or not there's still life on Mars, no one's dismissing that possibility either.
No, that's right. Exactly.
Fascinating story. You can read it at dailygalaxy.com, or you can do the geeky thing and read the paper at the Journal of Geophysical Research Planets. Gosh, Fred, we've covered a lot of territory and we're all done for the day. Thank you very much.
Pleasure, and great to revisit Mars again, your favourite planet.
Yeah, it's got a lot to tell, hasn't it? That's what makes it exciting. Yeah, we've got so much going on there, and there's always news almost every day coming out of Mars. Yeah, fascinating. Thanks, Fred. We'll catch you real soon.
That sounds great. See you soon.
See ya. And don't forget to visit our website between episodes. You can do that at spacenutspodcast.com, spacenuts.io. Have a look around. You can get your daily news feed through our website. You can visit the shop and buy yourself a cap or a shirt or a mug or a spiral notepad. Whoa, we've got everything. And don't forget, you can send us messages or send us questions through the Ask Me Anything tab at the top. That's all at spacenutspodcast.com. And don't forget our social media as well. It's a great place to visit other people or meet other people that listen to Space Nuts. That's the official Space Nuts Facebook page or the podcast group Facebook page. There are two. They're both very busy places. And thanks to Hugh in the studio, who couldn't be with us today because he's in Brisbane. That's funny for a lot of reasons that no one will understand. But anyway, we'll leave it there. And from me, Andrew Dunkley, thanks for your company. We'll catch you on the next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.